Please go ahead.
Thank you. So, good afternoon, ladies and gentlemen, and thank you, Professor Seugel-Klein, for your invitation to present the seminar and for your kind introduction. When I accepted this invitation, I assumed that I would give a progress report on our joint research project, which we call the Energy Ship Research Project. However, on second thought, I came to the conclusion that it might be of greater interest to the students to talk about the role mechanical and aeronautical and hydronautical engineering could play to respond to the twin emergencies we are currently experiencing, namely the climate change and the COVID-19 emergencies. The reason I want to do this is based on my awareness that most of my younger colleagues have quite different views how to respond to these emergencies. This is not surprising. Personal views are formed based on personal experiences. Most people now living in the United States and Europe were lucky enough never to have experienced a global emergency. In contrast, I have personal experience with two of them, namely World War II, when I was a teenager in Germany, just old enough to remember, but not old enough to understand the reasons for the emergency. The second emergency was a very interesting one for me. I was lucky to be able to participate in the Apollo project during the development of the Saturn space launch vehicle and to observe how the United States responded to the emergency caused by the launch of Sputnik. So the title, as you can see, of my talk is Can Mechanical/Aero/Hydronautical Engineering Bend the CO2 and COVID-19 curves? And there's a question mark there. So you will now assume that I will give you first the talk and then at the end give you the answer. But let me turn this around and I will give you the answer right away instead of at the end of my talk. So what is my answer? My answer is yes, of course, we can do something about these two emergencies, and mechanical engineering and aeronautical engineering can play a major role in that. Certainly as far as the technical aspects are concerned. Now, as far as the political aspects are concerned, that's a different matter, which I will try to respond to also during my talk. So as far as the climate emergency is concerned, the captain of Spaceship Earth, which of course is United Nations Secretary General Antonio Guterres, has already declared a state of emergency, and 38 governments have already joined to this emergency. So has now also President Biden, and he has already declared that he wants to reduce the CO2 emission by 50% by 2030. Next one, please. And now let's also talk briefly about the COVID-19. We already know that we have suffered 550,000 people who have died. And globally, they are now exceeding 3 million. So obviously, there is now a tremendous economic impact. So again, this is a true emergency, the most serious one in a long time. Next one, please. On the other hand, we of course should remember that mechanical and aero and aeronautical engineering have produced an incredible standard of living. So these are the successes of our profession. I can really say that, and the way I usually put it is we conquered space and time. By this, I mean we can fly to any point on Earth within 24 hours easily. And of course, we can communicate instantaneously with anyone on planet Earth. However, and that is not a big however, we did not realize when we achieved all these successes that there came a price with it, and that is the CO2 emission. So we entered into a Faustian bargain, which we now need to change. CO2 emission is indeed threatening the survival of humankind. That, of course, means that we should provide now emission-free power. And we also, of course, should protect ourselves from COVID-19 infection. So these are the two challenges I want to address. Next one, please. Now, we can express our increase in the standard of living by the amount of energy which we are able to access in our daily lives. So something like 300 years ago, they all had about 20 kilowatt hours per person per day. Nowadays, we can have something like 200 kilowatt hours and even more. Some people in some countries can go up to even 300 and 400 kilowatt hours per day. So this is a tremendous increase. It's an order of magnitude increase in terms of energy that we have available, a big, big achievement. Now, energy, as you well know, is measured in kilowatt hours. We pay our electricity bill in kilowatt hours, and power, which energy is per unit time, is measured in kilowatt. Next one, please. So remember the pioneers of modern science and technology. Obviously, it all started with Isaac Newton. 100 years later came James Watt, who showed that the chemical energy in coal can be converted into usable energy with a steam engine. And then about 100 years later came Nikolaus Otto in Germany, and he showed how you can convert oil, the chemical energy in oil, into usable energy in the Otto engine. Okay, next one, please. Now, we all are familiar with Newton's law. I don't need to repeat that, but the one thing which I want to emphasize and come back to is there's momentum, which is building up. So for instance, a body that is moving in a straight line will keep moving, as you well know, unless acted upon by a force. And that is the thing I want to emphasize. Now, the second law, of course, means force is equal to mass times acceleration. If you integrate that, in other words, you apply force on a body for a certain distance, you're doing work, and that, of course, is work, and that is the equivalent to energy. And that is why we are coming up with kilowatt hours. So we are owing that to Newton. Next one, please. Now there's another thing which we need to be aware of, and that is the explosive growth in the world population. Here it is, right? At 1830, we had 1 billion. 1930, about the time when I was born, 2 billion, and now we are approaching 8 billion. No, that is very unique in our human experience. Next one, please. Now, here's another such graph. Again, you see this explosion. And whoever drew this figured that maybe by 2100, we should level out at around 11 billion and should keep it there. That's pure speculation what happens. But the main thing which I want to emphasize here is this explosive growth. Next one, please. So here we have the CO2 emission. And it's a tiny amount that is contained in the atmosphere. It is expressed in parts per million. And here you see the increase in CO2 over the last years starting since 54. And it goes up and up. As you can see, it is now more than 400. It's around 415. The next one. Now, this is a new experience because we can go back and we have some measurements over the last 800,000 years, and you can see that CO2 fluctuated somewhere between 180 and did not exceed 300. But now we are up to 415. That is a situation which, again, is very, very unique and cannot go on like this. Next one, please. And of course, that means that the CO2 causes warming, as you well know. That's a greenhouse effect. And that, of course, means we have to have we will melt the glaciers and the ice, and that will cause flooding, and it will increase and has already increased by 20 centimeters the sea level, and it will continue increasing. Next one. So a lot of people, of course, are aware of this. James Hansen at NASA already in 1980 started to warn about this. Not many paid attention, but for instance, Jay Inslee, currently governor of the state of Washington, wrote a book, and he was, of course, very much influenced by the success of the Apollo project. So he called his book Apollo's Fire, Igniting America's Clean Energy Economy. He wrote that in 2008. Others also wrote books about it, for instance, Al Gore. And there's one engineering professor in Corpera at the University of Notre Dame who very recently also wrote about it. He called it a wicked problem. Next one, please. So let me quote here Inslee. He says in his book, opportunity is best found in crisis. Boldness is required. Tinkering at the edges did not put a man on the moon. We must reject the tyranny of the present. But then he also says there are no silver bullets. That, of course, is a very depressing statement. And all the other authors of these books and many papers which you can read came to about the same conclusion. Now, it's even worse because there's such a thing as irreversible climate change. There are tipping points which we're going to cross pretty soon. There will be unstoppable melting of the glaciers. It will go on and on. So indeed, irreversibility seems to be coming upon us pretty soon. The situation I would compare to the Titanic. The captain of the Titanic, of course, knew after the collision with the iceberg that his ship was doomed. He didn't tell the passengers right away in order not to cause a panic. He ordered the orchestra to keep playing, but of course, over time, they started to notice that the ship was tilting, and it was, of course, irreversible. We are also on a spaceship, and we have plenty of signs that we are dipping into a disaster. So something needs to be done fairly soon. And next one, please. So we need to change from fossil-based power generation to renewable power generation, certainly not later than 2050. So the question is this technically feasible? And is it politically feasible? And what about Newton's laws? And what about the momentum that has built up as far as fossil-based power generation is concerned? Next one, please. And there's another statement by a gentleman who is considered the top expert as far as energy transitions are concerned, Professor Václav Smil. And he writes that the energy transitions in the past have been very prolonged affairs because of the momentum that has built up and because of the expensive infrastructures. So he's saying that it's essentially impossible to greatly accelerate progress, even if we were to resort to some highly effective interventions. This is, again, a very depressing statement. Wouldn't you agree? Next one, please. But I would argue that there are other experiences where very rapid changes occurred. And World War II is certainly one such experience. And let me just give you the example. I was living in Germany at that time. And of course, we had to adjust very rapidly. I give you one example. Of course, we were running out of oil. It was only available for military purposes. The civilians didn't have any oil anymore. But we switched to wood gas. You may not know what that is, but it's not easy to handle this. You have to put branches from certain trees into a vessel and burn it, and then you produce gas, and then you are ready to go out on your trip. Not easy, huh? And then, of course, we had to substitute many materials and many foods. The word ersatz was the most commonly used word at that time, means substitute. We had no chocolate, we had no sugar, all of this had to be replaced, no coffee. Next one, please. So, but another lesson one learns from World War II, in my opinion, and that is the most important one, which I want to emphasize here, is how was victory achieved? Well, on the American side, in my opinion, they did it exactly right. And of course, they also had some material resources. So they used and produced in great quantity the readily available military hardware, trucks, tanks, airplanes, you name it. In contrast, Germans, of course, did not have those materials, and they had to develop new systems, superior tanks, airplanes, and rockets. And you will agree they, in fact, accomplished a lot in that regard. But it didn't do them any good because if you have only a few superior tanks and the other side has many of them, the other side will always win. And of course, they did. So the message I'm drawing from that is mass production is the thing to do. And what you should do is you should use the materials which you currently have available, the systems which you have currently available, and not go into new inventions because you don't have the time anymore. Next one, please. So that is also the case as far as the Apollo project is concerned. I know from my own experience, and many people don't know that, we had available lots of tanks and engines from the Jupiter missile, which was phased out, taken over by the Air Force. They had developed their own missile. So the proposal was, let's just bundle 8 tanks and engines to obtain the first stage of Saturn I, and increase, therefore, the thrust from 200,000 to 1.5 million pounds of thrust, and then increase it again on Saturn V to 7.5 million pounds, and that was sufficient to put astronauts into lunar orbit. And also that was designed and built in-house to save time and cost. So this is how it was done. And again, I emphasize this was done by using existing systems, existing materials, existing hardware. Next one, please. So as far as now our 2 emergencies are concerned, in my view, we have to produce existing systems in quantity. And the same thing, in my opinion, has also to be done as far as the COVID emergency is concerned. Next one, please. So now, how should that be done? Let's go back to the climate change. And here you see a picture of the ocean winds. There's a reason why our planet is called the blue planet. 70% of the surface of our planet is covered by water. And as you can see, there's a lot of wind or water in year-round, really. And the amount of wind energy that is available is at least 10 times of what we are going to need by 2050. So obviously, we have the material resources, we have the renewable energy resources, and now we have to tap into those resources. Because there's a conviction that I think many authors are expressing, the ones which I quoted, that if we just restrict ourselves to the resources we have on land and close to land, offshore, that in all likelihood is not sufficient to do the job. So how should we do this? The next one, please. Now, this leads to the energy ship concept I have mentioned in the beginning. How would one do this? How would one tap into the ocean winds? Well, in our opinion, obviously use existing resources. And what are they? Use existing systems, and obviously that is the sailing ship. So just put hydrokinetic turbines on these sailing ships. You can now take the electricity out of these hydrokinetic turbines, either store them in electric batteries, or even better, put them through electrolyzers and produce hydrogen, store this hydrogen, bring it back to shore from time to time, and build millions of such large sailing ships. Next one, please. And this is shown here. This is essentially our project here. I will show this in more detail at the end here. Next one, please. So how would one do this? Of course, one would use a ship which has a minimum of ship resistance. And these ships, of course, again, are available. These are hydrofoil ships. Look at the hydrokinetic turbine. Next one, please. Do such sailboats or sailing ships exist? Of course they do, right? Just look at the America Cup ships. These are beautiful machines. They are sailing at speeds which are 2, sometimes even 3 times the speed of the wind. So they can produce a lot of relative water velocity. And that, of course, means we can produce a lot of energy with such ships. Next one, please. And here you have, we have summarized this in a recent book, which I think is available for free to you. And here we go with this book. Next one, please. And so, since I will soon be running out of time, I think, let me now switch to the COVID-19 emergency. How should we tackle this problem? And again, I would like to go back to the World War II experience. And even if you like, go back to the World War I experience. Now, the Germans introduced the poison gas in World War I. It didn't do them much good, right? Because the other side was able to produce gas masks which were quite effective. The soldiers on the other side were still able to function. And so the conclusion is, as long as you have gas masks which allow you to function, you haven't done anything as far as having an advantage. Now in Germany, during World War II, almost every household, as far as I understand it, we certainly were given gas masks in our household, and I had to learn as a teenager how to put on such a gas mask. So I would say that there was a mass production of gas masks because the German government felt that maybe the other side is going to start poison gas warfare. It didn't happen. And I think that didn't happen, not out of humanitarian reasons, surely not, but simply out of the recognition that it is just not effective to go into a poison gas warfare, because it is not possible once you start throwing poison gas bombs to paralyze the population. The population, the people can still function, they can still rescue other people who are buried by the collapsing houses. So this just doesn't make any sense. That, of course, leads to the following question. And that is the main question I now want to ask as far as COVID-19 emergency is concerned. Are we not able to manufacture masks which are effective? And by effective, I mean masks which still allow us to function, to still go into department stores, still go into offices, and not do what is shown in the next view graph. Next one, please. What we are doing right now is we are going into a hard lockdown, and we are switching between hard lockdowns and also using these flimsy close masks. We should recognize that the function of a mask, of course, depends on what we really want to fight against. And COVID-19 infection is actually an easier problem, much easier problem than the poison gas problem, because poison gas surrounds you entirely. It will be around you everywhere. Not so as far as the COVID-19 infection is concerned. The primary infection source are tiny droplets, which we eject from our mouth and nose. They are subject to gravity. Let's go back to the previous one, please, for the moment. So they go down and fall towards the ground. Unless you are close to the mouth and nose of the other person, there's very little chance that you will actually get infected. So if you are not in a crowded situation, if you just look how much air is infected behind you, or more importantly, above you, then you will find, yes, there is what we call secondary infection. There are also very tiny particles that may flow upstream, or not upstream, but up at a height greater than your face. But there will be a very small distribution of such particles. So therefore, what we should do is, next one, please, not to do what we have done as a response currently, where we have gone into hard lockdown. Hard lockdown means, of course, that yes, indeed, we can protect ourselves rather effectively. That is true, but the price we are paying is enormous because then the economic activity essentially dies out. And we pay an enormous price in terms of economic losses. Now, if we go to the closed mass, as we now do, then we still have the requirement of social distancing, because we don't want to be sprayed by the other person with these tiny droplets. So the obvious question is, isn't there a third option? Aren't we able to do this much better? Now, something like that occurred to me already last year. And of course, what I was thinking about was my experience in World War II. These masks which we had obviously were very effective. But the other thing I was thinking of were our astronauts. They were walking and in fact driving their lunar buggies on the lunar surface. And their problem was much more difficult than this one, because they had to do this in a vacuum. So should we do this by just putting on spacesuits and having this big backpacks that the astronauts have? Of course not, right? That is not necessary. That would be overkill. But can we not manufacture masks which can do the job rather effectively? And my view is, yes, we can. Let's go to the next one. So what we want to do is we want to take in air which is essentially or almost essentially virus-free. So if we go, let's say, to the air behind us, in case it's not crowded, or above us, above our heads, then we should, of course, take in the air not close to our mouth and nose, but close to, let's say, in an air layer above us. And I call those snorkel masks. And it just so happens that I became aware of a colleague who had a sleeping problem. To put it very bluntly, he had a snoring problem, and his wife was not exactly happy about it. So he needed more air. So his doctor told him, well, I have some way of taking care of your problem. And he gave them he ordered the sleep apnea masks, and they are commercially available. Now, I also would like to mention that maybe these snorkel masks are not completely safe. They may be 95% safe, but vaccinations are also not completely safe, right? They are effective only up to 95%. Can we have actually a mask which is 100% safe? Yes, I would say that is possible. Just think of our firefighters. They have little containers on their backs, and they can provide themselves with clean air from that container for something like half an hour or up to 1 hour. So it's even possible to make what I would call firefighter masks. So these are the two types of masks which one should use, in my opinion. Let's go to the next one. Here's my colleague, right? He has this mask, which is commercially available, as I said, and look at this black box down there. Next one, please. Here's the mask again. It's easy, right? Next one, please. Here is the black box. And the black box could, for instance, be put underneath the shoulder of that particular person. In his case, of course, he would just put it next to him in his bed. But in our application, just put it on your back. Don't have a little backpack. And you could also, of course, easily attach a snorkel on it, vertically up, so that you can pump air from the air layer above you, which is essentially virus-free, and pump it into your mouth and nose. So that would be, I think, a possibility to essentially have a virus-free intake of air. So now I come to essentially the summary. Let me go to the next one. So I would conclude as follows. These two emergencies, of course, climate change and the COVID-19 emergency, are things which can be, to some extent, I would say to a large extent, be taken care of by mechanical engineering and aeronautical engineering methods, not so much, of course, as far as the COVID-19 problem is concerned. There we are trying to do this by vaccination. But think about it. We have lost now more people already in the last year in the United States than were lost in all the wars that were fought in the last century by the United States: World War I, World War II, Korea, And Vietnam. Was that really necessary? Should we have started with masks of the type I have described? Let me put the same question to the Germans. Right? The Germans at the moment, if you watch the news, are in a rather difficult situation. So is France, and so is India. Could they have produced, could they have remembered, could the Germans have remembered what they did in World War II? Could they have produced these masks? Could they have saved all that money which had to go into to make up for all the losses economically? Could that have been done? I would think so, that one could have done this much more effectively. Now, of course, so I would say from a technical point of view, surely that can be done. But what about the socio-political aspects? Will that actually be done? And that, of course, goes back to Newton's law, right? There is a tremendous momentum which has already built up. And for most people, it is very, very difficult to change. We are all used to certain things we don't want to change, even small changes. Now, to build these energy ships, of course, is in the eyes of many people a major change. Well, actually, it isn't, right? Compare this to what aerospace engineers have accomplished over the last 100 years. Nobody is wondering or is astonished that we can have 500 people going essentially in an aluminum tube from New York to Sydney in 19 hours or whatever it takes. Right? Nobody is astonished anymore that we were able to have astronauts land on the moon. Nobody is amazed anymore that we can shoot. We can operate a VW size thing on the surface of Mars to explore the surface of Mars. So in comparison to these accomplishments, the changes which are necessary in order to implement what I just described to you is really a very minor accomplishment because it is all available. These are all pieces which can be put together from available hardware. For instance, the sailing ships, of course, are available. They have been around for thousands of years. Hydrokinetic turbines are available. Electrolyzers are available. And certainly these masks can be produced. So let's think about that. Next one, please. So the outlook has to be that, yes, indeed, we can do these things, certainly as far as technical aspects are concerned. And so my message to you young people, and it is, of course, your future, which is at stake here, you can do this. We have done similar things in the past, as in particular as aerospace engineers. The task is not that difficult, but you have to convince a lot of other people who are resisting these changes because of the momentum that has built up. And they don't want to make these changes. They think this is way too difficult. This is way out of the normal box kind of a thinking. But it isn't. I hope I have convinced you that it isn't. So that also is my message to people such as Greta Thunberg, right? She's very concerned about this, and many of her age are also concerned, and they are demonstrating, and they are telling their older ones and the politicians do something about this. Well, it's not such sufficient to go into demonstrations. You also have to have specific solutions. So what I'm trying to get across here is, yes, it is possible to have specific solutions, and they should be pursued. So thank you very much for your attention. I think I have still a little bit of time left for answering any questions. And here is again, for additional information, you can look us up on email, write to us, and of course also look at the book which I just briefly indicated to you. Thank you very much. Any questions?
Thank you, Professor Platzer, for this very nice seminar. We have a few minutes for questions, live questions. Please unmute yourselves and ask the questions you may have. Anyone has any question right now?
I have a question.
Please go ahead.
Yeah, I mean, do you think that these firefighter masks can be used while you're flying, because when you fly, you are inside the airplane and then you are vulnerable because you can catch this virus easily. Can we saying that those who are flying, they should have masks like that, or we cannot put this in the inside the airplane?
Oh, I would say in the airplane, you probably could do this. I see no reason why you could have not these boxes, if you want to call them, with pressurized air in them. But I think in the airplane, it would actually be easier because you could connect to the air supply system in the airplane itself, right?
But that needs some technology change. But individually, you can buy this mask and and then you don't stop flying. You just can go flying, at least for short distances.
You mean when you are going into a normal airplane, into a commercial plane?
Yeah.
You could have this kind of, and you're talking about this firefighting.
Yes, that's the one you recommend, isn't it?
Well, I would also say probably the snorkel mask would be sufficient in many instances, even in the airplane. But yes, I think you could have these boxes with you, and you could have enough air, but probably only for half an hour, right, normally. But then you could easily tell the stewardess, give me another box. And she would have a store of such boxes. You exchange boxes and you go on for another half hour.
Yeah, because many people don't fly because of that. Now, that will help also the airlines to survive this economical.
Yes, oh yes, no, there are enormous economic impacts, right? Think about the trillions of dollars which we have spent right now, huh?
Yeah.
It's absolutely.
What type of firefighter masks you recommend? I mean, is there any brand you recommend for that?
Well, I don't think I should do that. I also stayed away from this mask, which
propaganda. It is helping this the community.
No, I would say you can Google all this, right? You can also Google this mask, which I showed for my colleague, right? So there's a company in San Diego, I shouldn't say anything more, and you can simply order it from them. Right?
The picture you show is the firefighter masks?
No, that would be the what I call the snorkel mask.
The what mask?
That is readily available.
What is the name of it? What's the name of it?
That is this sleep apnea mask.
Sleep apnea mask.
Go to your doctor and ask him to give you an apnea mask, and he will tell you how to get it. But you can actually order it directly from Google.
That for how long? How long that mask? For this?
That mask, I'm sorry that I didn't emphasize that. That mask, of course, you can wear as long as you like, right? You can go into the department store, and during your visit in the department store, you can put it on, right? There is no time limit. It will pump air for you. As long as your battery works, you will get.
When it comes, the air comes from the surrounding. That's already has.
It comes from an air layer above your head, and that's the important point I wanted to emphasize. Right? It does not come from the air very close to your mouth, right? Because that is where most of your virus is. But if you go into an air layer which is essentially virus-free, then you are in good shape.
Okay, let's see. We're almost, thank you for this question and discussion. We have maybe one last minute question. Anyone has a question? You can also put them in chat, or you can email directly to ipgs@ucdavis.edu if you like to.
We'd be happy to answer.
One more last question. Okay, it's now time for us to end our nice seminar, and we'll see you next time. Thank you again, Professor Platzer, for this very nice seminar. See you next time.
Thank you indeed.
Yes.